Second part of explanation about the alkanes nomenclature. What you see here is more complex in naming compounds of the alkanes. And what we should do first is follow the instruction, which is the instruction. It is more difficult to identify which is become the longest chain. So let's try to found the chain by start from the end of the chain. You may start here, 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 and here. But for the first, I'd like to start it from this carbon. Let's follow it to found out the longest chain. Put the number of every carbon to identify is it will be the longest chain or not. Let's start here. 1, 2, 3. If you continue to the left, it will give short chain, only 4, while there's still a lot of carbon that attach to these substances. Let's go bend to down and then we 3 and then followed by 4. If you go to here, it will end until 5. But it is possible if you bend, if you turn right, you will meet longer chain than 4, then try it 5. Let's try to continue straight to the right. 6 and 7. Continues, count from 4 to 5 and then 6 and 7. But it seems that it is more possible to make the counting goes to here 6 and 7. So we can cancel this as a longest chain, because when we use this as a longest chain, it will give more complex substituent then we make them as the longest chain. Go to down 6 and 7. Then what we have here, that the longest chain, it has 7 carbon. The 7 carbon, remember, it is give the name. The name is heptane. So put the name here before we continue with the next step. Heptane. Now follow by identify the alkyl of the groups that attach to the substances. The alkyl is the carbon that not identified as the longest chain. What we have here is this side, and then we also have this side attached to the fifth carbon, and then here and also here. You can classify that it has two kind of an alkyl groups, which is the first alkyl is CH3 and the name is methyl, and then the second group is C2H5, which is the name which should be ethyl. Then look at this point. When two or more substituents are present, list them in alphabetical order. That we have here the E and the M, while E is come before M, so we put first is an ethyl. Ethyl, it attached to the fifth carbon, so I will give the name is 5-ethyl, and then follow by the next group of methyl, which is it attach 1, 2, and 3 methyl, so we can add it as 3 methyl because it has 3, and we should also identify the carbon attached by this methyl, so we should put the number of each carbon. First is 3, then 5, and then goes to 6. Okay, we have here 3, 4, and 6 trimethylheptane. But remember that number of the alkyl, it should be nearest number. If we try to make it an opposite arrangement, with we make an opposite, it will be 1, and then it become 2, 3, 4, 5, 6, and 7. What we got here that the first methyl will attach to the second carbon. So we can cancel this name because it show more bigger number. What would be the name is it should be 3-ethyl 2,4,5,3-methylheptane. Remember that we can cancel this name because we may have the most nearest number of an alkyl groups that attach to the longest chain. Let's continue with the isomers. Isomers is iso means the same, and what we will discuss here is structural isomers. What is structural isomers? Compounds that have the same molecular formula but different bonding arrangement and hence different structure are called structural isomers. Different arrangement also will give the different names. That's why what we will try here is to identify how many isomers should be or would be exist for the substances. Let's try this. If we have the formula of hexane, which is C6H14, how many structural isomers can be identified? Let's try with the arrangement of this. To identify the arrangement, we should start with straight arrangement of the carbon because we have here 6, so I'd like to arrange 6 carbon that bond in the straight arrangement. We can complete this formula with the hydrogen CH2, 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 CH2 and H3C. For almost hydrocarbons that has straight arrangement, the name should be N-hexane. This is the first arrangement of hexane we have identified. Now goes to the second structural arrangement. What we should do is try to make one of these carbon as an alkyl, as an branch or as a substituent. So arrangement would be put as 5 atom carbon attached to other because one atom carbon will act as the alkyl or the substituent. I put the substituent in here. It will be similar with the first arrangement because it is the same arrangement. Remember, even though the arrangement is drawn by band, but it's still in the straight hexane. So we could not make this as the second structure. What I'd like to do is put one carbon as a branch or substituent in the second position of carbon. So we have here complete with the hydrogen. The name of this formula is because it has an alkyl in the second carbon, so the name should be 2-methyl pentane. Even though the name changed from hexane to pentane, but the most important thing is it has the same formula C6H14. This is the second structure that possible found as an isomer for C6H14. Could we found another isomer? Okay, let's try to make this alkyl move to the third carbon. I put 5 carbon that attach one to other and then put the methyl or an alkyl at the third carbon. Okay, we can complete here CH3, CH3, and then CH2, CH, and CH2. Okay, the name also because it has different structure, it will give the same and a different name. And as already do in the first step is
give the number of each carbon. It has 5 carbon, so the name is pentane. And this pentane attach methyl in the third carbon, so we put 3-methyl pentane. Now is it possible to put methyl in the fourth carbon as another isomer? If you move this methyl to go to fourth C carbon, okay, this is the fourth carbon, and then let's go to complete it with the hydrogen. Okay, now let's see that if you found out, even though in the first time you put it as 1 2 3 4 5 number, but the alkyl it should have the nearest number, so you have the opposite number arrangement. It should be 1 2 3 4 and 5, and it is not possible if you use this kind of arrangement. And this name of structural isomer is the same with the second structural isomer. It is 2-methylpentane. So this structure it could be cancelled as a isomer. Is it possible to put the methyl in the fifth carbon? The same approach is when we cancel the fourth methyl attached to the fourth carbon. It already for this formula structural, when only one methyl, it only give two kind of isomer, 2-methyl and 3-methyl pentane. Now, let's make the C6H14 two atom carbon as an alkyl, which means the same as methyl. So if we have 2 as methyl, then the longest chain should be butyl or 4. We have 4 atom carbon, and then we may possible put the 2 alkyl in the 2 and 3 of atom carbon. First, we make number 1, 2, 3, and 4. If we want to put 2 methyl, so it is possible to put them in this position. 1 in the second carbon, 2 in the third carbon. Then we can complete it with the hydrogen. The name of this is butane. The base name, the longest chain is butane, and it attached to methyl because it's same class group of alkyl. We can mention it as dimethyl, and then show the number of carbon that attach to it. So we put it 2 3 dimethyl butane. Okay, for the arrangement in C6H4, two atom carbon as an alkyl could give 2 3 dimethyl butane. Can we make another isomer? Let's try to change this methyl goes to the same carbon attached. 1, 2, 3, and 4. 1, 2, 3, and 4. Then we put the alkyl in the same carbon. CH3, 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 and CH. What we have here is 2.2 dimethyl butane. There is no other possible arrangement when we make 2 of this atom carbon become an alkyl. Now, let's try with C6H14. Let's make 3 of this become a alkyl. Is it possible? Okay. If 3 carbon become alkyl, so the longest chain become a propane. Okay, we can put it 1, 2, and 3, and then you can put it 1 here, 1 here, and you may put here 1. C and C, C. Okay, let's go here at arrangement. We still have the same name, 2.2 dimethyl butane. It means that the possible isomer structure that may be found in the C6H14 is only four of them. Longer the chain of carbon attached, it is possible to find more of the isomer structure.